little bit more transformations and coordinate geometry. Remember that a reflection is a flip over a line and that the distances do remain the same and they're perpendicular over here, like the distance from C to the line of reflection and then the line of reflection to C prime. A rotation is a turn around the specific point, and the translation is a slide. So let's label each of these transformations, and we're going to get a little hint as to what we're doing today since we're working in the coordinate plane. So you have four choices, 1, 2, 3, and 4, and it can be reflected over the y-axis or across the y-axis, reflected across the x-axis, rotated 90 degrees clockwise, or is translated 7 units to the right. Go ahead, let's try to work them all out. Go ahead. Okay, so this first diagram in the upper left, that is a picture of a reflection over the y-axis. Okay, you can see that the y-axis forms the line that splits this image in half, the image and the pre-image. Okay, let's go next to the graph in the top right over here. That is a translation. It is slid. It has slid in 7 places to the right. Now the bottom left. That is a reflection over the x-axis. It's flipped over the x-axis. Notice if I count from B prime, it's 1, 2, 3 places, and to B is 1, 2, 3 places. And we're going to use that expression count and repeat frequently in the lesson, at least in the beginning part. And lastly, we have spun this triangle ABC 90 degrees clockwise. We turned it 90 degrees clockwise. So there we go. And those are, with the exception of dilations, which were not included, what we're going to cover today. So don't feel awkward if you didn't get all of those right. Just know that that's what we're going to talk about today. And hopefully by the end of today's lesson, it all makes a lot of sense to you. Okay, so next up, let's just see you construct the line of reflection for the following reflections. Now, we could use the constructions with a compass and a straight edge, but that is one of the few limitations. There's a lot of great things about online classes, but there are some limitations to online classes. And the online class limitation that I find biggest is how to do constructions. For those of you who know how, you would do the perpendicular bisectors between the point and the image and the pre-image, but we're just going to draw a line best we can. That would be the line of reflection for each of these. So go ahead, do that. Okay, for A, there it is. And for B, there it is. Oh, there it is. Oh, there it is. All right, so we start off, I should have labeled A, B, C, D. I did not. On all the subsequent problems, I do. Draw the reflection of A, B, C, D when you reflect it in the x-axis. So that means we're going to flip this over the x-axis. And the way we do that is we count and we repeat. So I'm actually going to do this a little bit backwards. For the introductory one, I'm going to show you the answer and then show you how we got it. There's the answer. Ready? Okay, here we go. I'm going to start with this point here. I'm going to count down 2 more. This point, down 8 more. This point, down 4 more. This point, down 7 more. In other words, literally, you could count them. For starting here, 1, 2, 3, 4, 1, 2, 3, 4. And in each place you make a mark and then you connect the dots and you have your reflection over the x-axis. What I want you to notice about this is that the x-coordinate, whenever you reflect over the x-coordinate, the x stays the same. For example, the blue triangle is the beginning triangle. It's -8, 2. The image would be -8, -2. So the -8 stays the same. Here we have -3, 4. Here we have -3, -4. Here we have 0, 7, its image, 0, negative 7. So notice in each case, the x stays the same. Here we have 7, 8. Here we have 7, negative 8. So when you reflect over the x-axis, the x-coordinate stays the same. Okay. Now we have triangle HIJ with those coordinates. So there's triangle HIJ, and we draw the lines that connect them. So there's triangle HIJ. Now this time we're going to do it so that we reflect over the y-axis, not over the x-axis. So if I reflect over the y-axis, it's what I like to say, count and repeat. So let's start with H here. I'm going to count 2 places, 1, 2, and then repeat, 1, 2. So that gives me these coordinates. There's H prime. Now let's try this coordinate up top here, 1, 1. Let's try J to J prime, 1, 2, 3, 4, 1, 2, 3, 4. And of course, we connect the dots. And if you look, it looks like a mirror image around the y-axis, and that's what we were reflecting over. Notice the y-coordinate stays the same. From the point negative 2, 0, it became positive 2, 0. The x changed, but the y stayed the same. The j, negative 4, 3, became positive 4, 3. So, sure, the x changed, but the y stayed the same. I was 1, 3, negative 1, 3. It became positive 1, 3. So, the x-coordinate part, when you reflect over the y-axis, gets negated, and the y part stays the same. So, in summary, when you reflect over the y-axis, the y stays the same. The x gets negated. When we reflect over the x-axis, the x stays the same and the y gets negated. So whatever axis you're going over, that coordinate, part of the coordinate, stays the same. The other one gets negated. That's the summary for both of those problems. Okay, let's try the next one. Go ahead, stop and start. Draw the original, draw the result. Okay, so here is the original triangle, ABCD. Now we're going to reflect over the y-axis. So that means the y is going to be in the middle, and in each case, the x will be negated and the y will stay the same. So let's check it out. C, count and repeat, 1, 1. Notice the y, negative 4, is staying the same. The x is going from negative 1 to positive 1. For D, it's 1 to the axis and repeat. For A, it's 2 to the axis and repeat. And for B, you're on the axis, so you don't need to go anywhere. In every single case, the y stayed the same and the x got negated. And there's my resulting figure. When you reflect over the y-axis, the y stays the same, and of course, the x gets negated. Okay, now we're going to reflect in the origin being the point where the two axes meet. So let's mark the point 5, 1. Since I'm reflecting in the origin, I want to count and repeat again, but I want to count and repeat to the origin. So I'm going to go over 5, down 1, over 5 more, down 1 more, and there's my image. So notice again, I want the origin to be in the middle, so I'm going over 5, down 1, over 5 more, down 1. We like to say count and repeat. So I counted to the origin, over 5, down 1, and I repeated over 5, down another 1. So 5, 1 became negative 5, negative 1. So in a point reflection, which is also a 180-degree rotation, in general, xy becomes negative x, negative y. 5, 1, negative 5, negative 1, xy, negative x, negative y. Okay, let's do a reflection over the x-axis. You do it from beginning to end, and I'll do stop and start, or you do stop and start. Okay, so here we have our original triangle, and we're going to reflect it over the x-axis. That's the horizontal axis. So count and repeat. 3, 3, and then 0. So there are my points. Connect the dot. There's my image. Count 3 down for I. 3 more down is I prime. J, 3 down, 3 more down is J prime. H is actually going to stay exactly where it was. When you reflect over the x-axis, the x stays the same, the y gets negated. Okay. Next up, we have this point 2, 4, and it's going to be reflected over this point here, the black point, which is 5, 6. So I'm going to count up 2 over 3. I repeat, up 2 over 3. There's my new image, and I draw my resulting image. In general, oh, that's when I reflect over 180 degrees. Ignore that. Ignore that. This is not through the origin. Okay? It has to go through the origin for that to be true. Completely ignore that setup right there. The correct coordinates here, 2, 4, is going to become 4, 7, and then it's going to become 4, 7, or I should say 2, 4 becomes 5, 7, and let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay. So let's reflect the point 2, 6 in the origin. The answer obviously is the red one. Let's hope you're able to get it. Okay, count and repeat. Right? You're going to go down 6 over 2. So go down 6 more over 2 more. You get the correct answer. Okay? So that will cover our review of reflections on coordinate plane, or our teaching of reflections on coordinate plane.